Hi, welcome to my channel. I am Devakar, and today I am going to solve today's daily question on LeetCode. It is largest positive integer that exists in with its negative. So let's quickly go through the question description. Okay, so given an integer array nums that doesn't contain any zeros, find the largest positive integer k such that minus k also exists in the array. Return the positive integer k, and if there is no such integer, return minus 1. Okay, so example 1, number nums is equal to -1, 2, -3 and 3. So see here the largest number is 3, right? And -3 is also -3 also exists. So then we have to return 3. Next example, it is -1, 10, 6, 7, -7, 1. Okay, the largest number is 10, but -10 doesn't exist in the nums. So later on the 7, the next maximum number is 7. So does -7 exist? Yes, -7 exists here. So we have to return only 7. And now example 3 is -10, 8, 6, 7, -2, -3. The largest number is 8 here, right? And minus it doesn't exist. So next largest number is 7. -7 also doesn't exist. Next largest number 6, but 6 -6 doesn't exist. So we have to just return -1 because it is clearly stated in the question that if there is no such integer, return -1. Okay, so how can we solve this question? So we can do one thing. So first of all, go to the brute force, apply brute force approach. So use two for loop for that. Okay, so let's solve the question. Okay, so let's check an integer answer and initialize it with -1. Later on use for loop, auto, or you can use integer also, int num1 nums. Okay, second for loop here, int num2, right, in nums. So now if num1 is equal to minus of num2, that means if num1 is positive and we have find out that num2 and that num2 is negative, then minus of num2 will result positive num2, right? So if num1 and num2 is equals, but in but different sign, right? So then only we can write this answer is equal to max of answer and absolute of num1, because we don't know that whether num1 is positive or num2 is positive. So that's why I'm using absolute here. So num1, okay, that's it. Now return answer. So now quickly run the code. Okay, let's see. Okay, oh, sorry, I forgot to. Okay, put it here, right? Parent. Okay, let's submit it again. Sorry, run it again. Okay, it's run perfectly. Let's submit. Okay, got it. So now quickly discuss the time complexity. So you can see that we are using two for loop, and each for loop runs for n times. If n is equal to num size, so num size, so we are using two for loop, right? For loop that runs from 0 to index 0 to n, where n is equal to nums dot size. or inside it there is another for loop that also runs from index 0 to n. So that's why time complexity will be big of n square. And did we use any extra space? No, we didn't use any extra space. So the space complexity here will be big of 1. Okay, let's okay. So in last approach we have solved the question in big of n square time complexity, right? So can we did it and do it in, or can we improve the time complexity? Yes, obviously we can improve it. So how we gonna do that? Okay, so let's take an example here, right, before going forward for the next approach. Now take example, right, -3 -2 1 -3 sorry, +3. The random example here. Okay, let's take another example here. -3 -2 1 3 10. And another example, -7 -3 2 1 3. So you can see that every sorry, this is not sorted yet. Okay, let's change it. You can see that every array is sorted. Every element in three array is in these three arrays is are sorted, right? So now if we initialize two pointer, one that points to the left element and another that's point to right element, right element of the array. So if absolute of 3 equals absolute of -3, yes. And so we have found the answer yet, answer, so which is 3, right? So and next on, see that the left pointer that points to -3 and the right pointer that points to 10 isn't equal, right? The absolute of 10 isn't equal to absolute of -3. And as the array contains both negative and positive integer, so if we sort the array, the negative elements will be in left side and the positive element will be at the right side. So here you can see that 10 is not equal to -3, or absolute of -3 isn't equal to 10. So if we decrease the right pointer value by -1, so if so r minus minus, now r points to this, right, 3. So now absolute of 3 is equals to absolute of -3. So we have found the answer. So the return 3. Now the next question, the maximum element, the maximum number, which is 3. Here maximum element is 3 here, right? So we are as we are using two pointer approach, we will not see that in this way. So the left element is 7, the left pointer points to -7, the right pointer points to 3. Now see, the absolute of -7 and -3 isn't equal, but absolute of -7, that is 7, is greater than 3. So here there will be possibility that if we increase the L, then we can find out element that which absolute will be equal to 3. So if we now increment L pointer here, so now L points to -3, and if we see that the -3, absolute of -3 is equal to 3, so we have found out the answer, right? So what is the purpose of this? So as we are using two pointer and in and while loop, we'll break down the whole code in three steps. You can say that if left pointer element and right pointer element is equal, obviously absolute of each element is equal, then just return 3. We don't need to do anything. But if absolute of 3, absolute of left element um, is less than absolute of right element, then we need to decrement, or we need to decrease the r pointer. And if the absolute of left element is greater than absolute of right element, then we need to increase or increment the L pointer value by 1. And so you can now I think it is understandable. Okay, so here I will write an algorithm. So L pointer will points to 0 and R pointer will points to n minus 1. We'll use a for while loop here, L less than R. Okay, if um, nums at L, please see that nums at L will always be uh, negative if the array contains negative value, right? So the minus of nums L, if it is equals to nums R, that means the maximum value of that array equals to minus of the leftmost element, then only we will return nums R, because we have found out the answer, right? And else if nums minus of nums L is less than nums of R. Please see, nums at R is always positive, and minus nums L will be positive, right? And if positive of L, nums L is less than nums R, that means we have to decrement the R value here, because in this array, maximum element is 10. So positive 10 exists, but minus 10 or negative 10 doesn't exist here. So we just need to decrement the R pointer value by 1. So we'll decrement it R minus minus. That's it. Let's okay. And else that means else if minus of nums at L is greater than nums at R, then we'll increase in this scenario, we'll increase L pointer by 1. So L minus minus, and after that we'll return our return minus 1, right? Because the case where both maximum element exist and the negative of that maximum element or maximum integer also exist, in that case we'll return it right here using this case. So if doesn't exist, then in outside of the while loop we'll return minus 1. So let's go to the code section here. Okay, let's write the code here. So we first need to sort the array or vector nums dot begin, nums dot end, sorry, two pointer L that points to 0 and R that points to nums dot size minus 1. Now use while loop. Inside while loop we just need to write L less than R if minus of nums at L is equal to nums R. We just need to return nums R. Okay. Else if minus of nums L is less than nums at R, then R minus minus. Else if minus of nums L is greater than nums R, then L plus plus. So this section is done, right? Now come outside of the while loop and return minus 1 if doesn't exist. If the negative of the largest integer doesn't exist, then we just need to return minus 1. So okay, let's run the code. Okay, let's submit it. Okay, so as of now we have used brute force approach, then two pointer approach, and so now discuss the time complexity here, right? So the time complexity here that you can see we are it will be big of. So let's discuss the time complexity here. So in this code you can see we first we have sorted the array, sorted the vector. So for sorting the time complexity will be big of n log n for sorting, and for this while loop the time complexity will be big of n. So the overall time complexity, will be big of n log n, and as we didn't use any extra space, you can see so that's why the space complexity will be big of on here. Okay, so that's it. Now here we can improve another approach. Using another approach we can improve the time complexity, but it will cost space. So the space complexity will be big of n, the approach that we are going to use now. So what we'll do here now, so in this approach we'll use a unordered set. So you know that set only take the element that is distinct. If inside the array there is multiple occurrence of the same element, it will not take all of those elements, it will take only one. So and later on we will use a for loop, and we will check that if the negative of that element uh, exists or not, because inside inside the set we are going to insert the negative element, negative num. So without talking too much, let's solve it. So as said, unordered set of integer, let's name it as st, Okay, that will be totally fine. Now using for loop for inserting every element, sorry, nums. Now we'll check here if num is less than 0 or not. If it is less than 0, then only we are inserting it into set. So st dot insert num. Now again we will use a for loop and we'll check. Okay, sorry, I forgot. And then using answer variable. So let's check an answer variable, integer answer, and initialize with -1 here. So we'll check that if the num is greater than answer or not, and we'll check that st contain the negative of num. So now see if the nums contains all the elements, right, the negative and positive. So in this, if inside the if statement, if num is greater than answer, so if num is negative, then the if element, if statement will not be considered, right? And if it is positive, the num is positive, then we'll check that if num is greater than answer. The right now the answer is -1. So if it is greater than -1 and the st, the unordered set, if it contains the negative of num, then only we are updating the answer, which is answer is equal to num, right? So let's return it, return answer. So before that, let's do dry run st here. Okay, st. So the example that we will take here, -1 to -3 3, -1 -1 on -3 3. So now now we are checking, using for loop we are checking that if num is less than 0 or not, right? So first number, which is -1, it is less than 0, right? So we will insert it into stack, sorry, stack not, it is a another set, so -1. Later on the next element is 1, so 1 is not less than 0, so we will not insert it. Later on -3 is negative or less than 0, we will insert it into another set. And the next element is 3, so 3 is not less than 0, so we will not insert it into st. Now as we have initialized the answer variable to -1, right? So using for loop, if num, so the first element is -1, so -1 is greater than answer. No, -1 is not greater than answer, so we will not do nothing, we will do nothing. So answer is -1. And next element is 1, so 1 is greater than -1. And does st contains -1? Yes, st contains -1. So answer will be updated to 1 here, right? Next element is -3. So -3, now -3 is, it is greater than 1? No, it is greater, it is not greater than 1, so we will do nothing. Next element is 3, so is 3 greater than answer? The answer is 1, right? Yes, 3 is greater than 1. And now check if st contains minus of num. Minus of num is, the num is 3, right? The minus of num is -3. So does it contain -3? yes, it contains minus 3. So the now answer will be 3. Answer will be 3. So now the answer will be returned. So this is the answer. So it will be returned. It will be returned. So now let's take another example. Let's take another example. Okay. So another example was minus on minus on 10, 6, 7, minus 7, 1. So ST. So ST will insert minus 1 because minus 1 is negative. 10 is less than 0? No, 10 is not less than 0. Next element 6, is it less than 0? No. Next element 7, is it less than 0? No. Minus 7, it is less than 0? Yes, it is less than minus 0. So we will insert it into ST. Next element is 1. So is on is less than 0? No. On is not less than 0. So what we will do now? Now answer is initialized to minus 1. Now again traverse the num. So first element is minus 1. So if num is greater than num is minus 1, right? The num minus 1 is greater than minus 1? No. So we will do nothing. Then num is 10. 10 is greater than minus 1. Yes, 10 is greater than minus 1. But does ST contain minus 10? Minus of, because the current element is 10. So minus of so negative of 10, that is minus 10. Does it if it is inside the ST? No, it is not inside the ST. So we will do nothing. Next element 6. Is 6 greater than minus 1? Yes, 6 is greater than minus 1, but ST doesn't contain minus 6, right? So we will do nothing. So next element 7. So 7 is greater than minus 1. Yes, 7 is greater than minus 1, but and now check if ST contains minus 7. Yes, ST contain minus 7. So we will do something. What we will do? We will update answer to 7. The last element is 1. If 1 is greater than answer, the answer is 7, right? Last integer to which we have updated answer. So it 1 is greater than 7? No, 1 is not greater than 7, right? So we'll do nothing. So just simply return answer. Answer is which is 7. Okay, I think you have understood all of this. So let me erase it. So now discuss the time complexity here. So time complexity will be big of n plus big of big of n. So overall will be big of n, because we didn't sort anything, right? We didn't take any other thing to that cost us too much time complexity. We have used only 2 for loop, which is separate. So overall time complexity will be big of n. And space complexity, did we use any extra space? Yes, we did use extra space, which is another set. So in worst case scenario, it will cost us of n space, right? So the space complexity will be big of n here. Okay, so now run the code. Okay, successfully run. Now submit the code. Yes, so that's it. Thank you for watching the video. Please like it if you found it helpful, and if you are new to this channel, please subscribe.